According to the National Committee on Effective Assessment, every educator must thoroughly comprehend the interrelationships between three key aspects of the assessment process. First, cognition or learning theory. Next, observation. And third, interpretation. Each of these three elements impacts the validity of inferences that can be drawn from data gathered through student assessment tasks. This video focuses on the observation pillar of the assessment triangle. Designing effective educational assessment tasks should never be done on the fly. Assessment tasks should not be designed or selected arbitrarily. The assessment task must allow students to explain, show, or create something to demonstrate their competence. This video explores research-based principles of educational assessment design to be considered by classroom teachers in order to gather reliable and fair data to support valid inferences about the level of student competency in any domain of study. First and foremost, assessment design begins with the end in mind. In other words, the educator must have a clear understanding of what she wants to know about student competency before she begins to create or choose an assessment task. Every assessment task, whether it be a pencil and paper test or the judgment of a performance, must align with a model of learning that describes the latest research about how a learner develops competency in a domain and identifies what is most crucial for the student to learn in the domain. I have discussed the construction of a model of learning in another video, so let me simply say here that a model of learning guides all instruction and assessment. Designing tasks for gathering data about student competence involves consideration of three important elements. 1. The kind or type of assessment task. 2. The scoring criteria that discriminate among various levels of competency. And 3. The administration procedures to be used in preparation for and in conducting the assessment. Choosing the type of task to enable students to demonstrate their competency requires careful consideration and greatly influences the type and validity of inferences that can be drawn from the data gathered. The ability of students to transfer competence from the learning context to the assessment context is a major consideration in developing or choosing an assessment task. In considering the transferability of knowledge from one situation to another, there are, at first glance, seemingly conflicting recommendations from research. On the one hand, research validates the importance of mirroring in the assessment process the way students initially acquired competence. In other words, effective assessment tasks are designed to reflect the context in which students initially learned what is being tested. For example, if students were taught to shoot foul shots by practicing shooting them in a gymnasium, then the assessment task should take place in a gymnasium with the data being gathered as the students shoot foul shots. On the other hand, if the students heard a lecture or watched a demonstration on the steps involved in shooting a foul shot, then the assessment task should simply require students to list or demonstrate the steps. The conflict surrounding the transferability issue comes from the research dealing with expertise. Research that has attempted to differentiate between experts and novices in a field suggests that experts are able to transfer what they know or can do to novel situations, rather than simply being able to perform them in exactly the same context in which they initially acquired their competence. For example, expert readers can transfer their knowledge of phonics to any unknown word they encounter in print, not only to the words they encountered during the instruction of sound symbol mapping. So what types of tasks should be used to assess student competence? One that mirrors the context in which the knowledge or skill was learned, or one that requires the student to transfer the knowledge or expertise to novel situations? The answer to this conundrum about the type of task to be created or chosen to ensure transfer of knowledge from one context to another is determined by the inferences that the teacher intends to draw from the data gathered. In other words, is the data gathered to be used to document foundational knowledge or skills, or is the data intended to reflect expertise as defined by the ability to apply the knowledge in novel situations? If the former, then the observation task should mirror the context in which the knowledge was initially learned. If the latter, then the observation task should require students to apply what they have learned to a novel situation. The issue of transferability not only addresses assessment practice, but it also addresses instructional practice and methodology. If the purpose of instruction is to develop expertise in a field, then the initial instructional context must be designed to help students to not only understand specific knowledge and skills, it must also extend the understanding of when and under what conditions the new knowledge or skill can be applied. Thus, multiple and diverse contexts in which the new knowledge is rehearsed and applied must be part of the initial learning situation if expertise is to be promoted. Once the teacher has selected the type of assessment task that best supports the inferences she intends to draw from the data, she must determine the criteria for evaluating students' responses. Again, the scoring criteria must align with the level and type of learning identified in the model of learning. Data gathered from the assessment task through the scoring method should distinguish between such levels as novice, competent, and expert relative to the extent of their understanding or skill. Oftentimes, a numerical average or percentage is gathered as evidence of student competency, but this type of scoring limits the type of inferences that can be drawn and oftentimes provides little insight into instructional effectiveness. Typically, more information about a student's performance than simply the quantity of his or her learning needs to be inferred from the data. For example, simply recording the number of words a student can read in a minute provides very little information that can help the reader to improve. In other words, such data does not indicate the type of words the student mispronounced, skipped, or omitted, or why they missed them. This is important data for teachers to know if they are to help students improve their rate of reading. Sometimes response time may be a criteria for inferring some knowledge or skills. For example, allowing a child 3 minutes to identify a letter name and then recording that the student can recognize the letter correctly is not going to allow the teacher to draw a valid inference about the student's automatic recognition of the letter names. Nor will the extended time frame help the student to read fluently, because that process requires automatic letter recognition within nanoseconds. To be useful to students and teachers, the scoring criteria must be written in such a way as to identify not only how many students performed at a particular level of expertise, but also to indicate why students did or did not perform at or above a competent level. The third element to consider in the design of assessment tasks is the procedures to be adhered to in conducting the assessment. Administration procedures influence the fairness of the assessment of student competency and the validity of the inferences that can be drawn from the data. Procedures must attempt to eliminate any extraneous features or situations that interfere with the student's ability to demonstrate his competency. For example, if the target skill of an assessment is the student's ability to use their mathematical knowledge to solve problems, and the assessment task requires considerable reading on the part of the test taker, then the requisite reading skills may interfere with the assessment of the student's math competency. Such procedural issues can result in a false analysis of some students' mathematical competency. In summary, considerations about each of the three elements of an assessment task, the type of task, the scoring criteria, and the administration procedures, influence the results and the inferences that can be drawn from the data. Teachers tend to spend considerable time designing engaging, authentic learning experiences for students, but research validates that if educators want to facilitate learning, we must plan instruction and assessment by beginning with the end in mind. We must first design a model of learning to determine what we need to discover about students, and then design assessment tasks that will gather data about what we need to discover. These two tasks should be completed before we jump into designing instruction or learning experiences.